second batch will be assigned to the same computer. Like this, the jobs are submitted to the computer for the execution purpose batch by batch. One batch after execution of the batch 1, next batch will be executed, batch 2 and batch 3, so on. Like that, batch by batch, the jobs will be submitted for the computer for the execution. So this is about batch operating system. But here the problem is CPU idle time is more. The CPU may sit and idle for the long period of the time because one batch is completed. After that, the operator has to submit batch 2 related jobs. So until that, the CPU has no work. So to overcome this problem, next type of the operating system was introduced, that is called multi-programming operating system. The main concept of the multi-programming operating system is they try to reduce the CPU idle time. We want to give more and more work to the CPU in general terms. See this image. Initially, all the files about any user stored in the secondary storage devices. Nowadays, we are using hard disks or SSDs, solid state drives, as a secondary storage devices. That is a permanent memory. If you store your data, that will be available at any point of time because that is a permanent memory. And whenever you want to execute any program, that relevant files must be transferred from secondary storage to main memory. Main memory is nothing but RAM, that is primary memory or main memory. And in the main memory also, the OS occupies some part. This is called operating system part. And remaining part is used for the user programs execution. Okay, this is OS part. Assume that we are trying to executing 3 programs. Program A, program B, program C. You can give any name. For the simplification, I'm giving the names A, B, C. And assume that at this particular moment, the CPU is executing programming C. Program B is being executed by the CPU. Execution in process about the program B. When the execution of program B completed, automatically C will be submitted to the CPU for the execution because that is in the waiting state. That is waiting for the CPU time. Like this, multiple programs are available in the main memory, or multiple programs are loaded into the main memory. Whenever the execution of one program completes, automatically the program which is in the waiting state will be submitted to the CPU for the execution. Like this, we can improve the efficiency of the CPU, or we can execute more and more programs with help of the CPU. CPU utilization is improved. So this is about multi-programming operating system. Next category is multi-processing operating system. Multi-processing. You can remember like this, multi-processing uses multiprocessors. Okay. Multi-processing is used multiprocessors. So in this category, we use multiple processors, multiple CPUs. Okay. Multi means more than one. More than one processors we are using to process the programs, to process the tasks or jobs. That is why this is called multi-processing operating system. A multi-processing operating system is defined as type of the operating system that makes use of more than one CPU to improve the performance. Obviously, suppose we have one work If you give that one work to the one person, that person may take 10 minutes, let us assume. The same work, if we divide it and given to the two persons, that work can be finished by 5 minutes only, half time, because two people are working with the same work. Two people are doing the same work. So in the same way, if you are using multiple processors, multiple CPUs, obviously the performance will be improved. So that is the main concept in multiprocessing. Multiprocessors work parallelly in the multiprocessing operating system for the given task. If you give any task, the task is divided and that part of the task will be executed by the different processors. Suppose I submitted one task, that task or job divided into two parts. One part is given to the CPU 1 and another part is submitted to the CPU 2 for the execution. So parallelly, the same work will be done by the multiple processors. All the available processors are connected to peripheral devices, computer buses, physical memories, and clocks. So here we are using two processors, but remaining all components, all the collections will be maintained for these two CPUs. But important point is single main memory is maintained because everything the CPU wants to execute that must be loaded in the main memory, and the CPU has to access the data if the data available in the main memory only. CPU cannot access the secondary storage device directly. That's why, even though we are using multiple processors, the main memory is maintained as a single component. Single main memory is only maintained. So this is about multi-processing operating system. Advantage, increased reliability. Suppose we are working with a multi-processing operating system. Assume that CPU 1 is failed. CPU 1 is not working properly. There is a problem with CPU 1. Assume that. So obviously we have the second hand, that is CPU 2. We have alternate. So CPU 2 will take care about the execution of that program. So this is the meaning of increased reliability. Even though some failures are occurs while executing any process, as we have the another processor in the multi-processing operating system, the same job or same task will be executed by the another processor. Next, increased throughput. As I said already, throughput means number of the processes executed by the CPU per unit time. That is called throughput. So we are using multiple processors. Obviously, we can execute multiple programs. The CPU, multiple processors we are using. So the operating system can execute more programs because two processors or three processors are there. Obviously, number of the programs will be executed also will be increased. That is the meaning of increased throughput. Coming to the disadvantages, they are difficult to implement process scheduling and resource allocation since we involve more than one processor. So, as I said already, multiple processors are there, multiple process might be we have, and multiple processors are take care to execute multiple processes. But the problem is how the procedure will be. There must system knows how the particular CPU knows which process only executed or which process should not be executed. That CPU must have the knowledge. So for that we need to use scheduling algorithms. But here we are using multiple processors. So that is why it is somewhat complex to implement CPU scheduling algorithms also, as we have multiple processors here, multiple CPUs. And next disadvantage is all these software may not be compatible with multiprocessing. Okay. We may use different type of these softwares in the operating system, but all these softwares may not work properly with the multi-processing operating systems. Generally, all these softwares are work well with single processor operating system. Obviously, whatever the systems we are using, probably all are single processor operating systems only. We have one CPU. Next category, time sharing operating systems. Observe this image, you can understand the concept easily. We have one CPU, and one CPU can execute the task. The task might be belongs to any number of the users. Okay, different users are connected to the one CPU. Assume that user 1, user 2, user 3, and so on, user 8. 8 users are connected to the single CPU, and this single CPU is going to execute all the jobs related to all these users. 8 users programs can be executed by the single CPU. So here the word time sharing means the CPU gives some slice of the time to the each and every user. Let me give a simple example to understand this concept. Suppose the CPU gives some slice. Slice means a little bit of the time. Assume that 2 seconds. Assume that in this example, the CPU slice time is 2 seconds. 2 seconds will be allocated to the user 1. Next 2 seconds will be given to the user 2 task. Next 2 seconds will be given for the user 3 task, and so on. The meaning is, all assume that all the 8 users submitted their task to the CPU. Only one CPU is there. One CPU has to execute all the jobs. But the working procedure is, user 1 task will be executed first 2 seconds. First 2 seconds only. The task may not be completed. Even though the program is not completed, the CPU switches from user 1 task to user 2 task. And next 2 seconds, user 2 job will be executed. That may or may not be completed, the complete task. And the next 2 seconds will be given for the user 3 job. Like that, every 2 seconds will be given to the different users. So with this, the user may get the feeling that all the users' programs are being executed simultaneously. But actually, that is not true. Internally, the operating system uses time sharing concept. Okay. So the time sharing operating system, computer resources are allocated in a time dependent fashion to these several users simultaneously. So it helps to provide a large number of the users direct access to the main computer. Okay, they are getting the feeling that their jobs are executing simultaneously. So in this, the CPU is switched among the multiple programs given by the different users or on the scheduled basis. Schedule means depending on the time. The scheduling time is 2 seconds, let us say, time slice. Depending on that, it's rotate. 2 seconds for user 1, 2 seconds for the user 2, and continues. The clock is continuous. Advantages: the time sharing operating system provides effective utilization and sharing of the resources. Obviously, only one CPU is there, but as per our example, 8 users are connected to the same CPU. So resources are shared. CPU is shared among the 8 users. And this time sharing operating system reduces CPU idle time and response time. Okay, reduces the CPU idle time. Then coming to the disadvantages, it uses a lot of resources. Resources means CPU time, memories, all are called resources in the operating system context. It uses lot of resources to implement this time sharing operating system because it is switching from one user task to another user task. And next time that has to resume the task where it was stopped. To know that also it uses some techniques internally. So like that it has to use so many resources. So that is also one of the disadvantage. Hardware with high quality is required because complex tasks are we are implementing, multiple users tasks are executing by using single CPU. That's why the quality of the hardware is also must be maintained. Next disadvantage is there is no proper security in this because as I said already, users data is stored in a CPU. Only one CPU is trying to executing all the users data. All the users data is available with CPU. So there is no proper security if we load the data into that such type of the servers. Next category is distributed operating systems. If you observe this image, you can easily understand the concept. What is the working nature of distributed operating system? Distributed. The work is distributed simply. Okay. By observing that word, you can get some idea. Distributed operating system. In this type of the operating system, what is the work you want to do with operating system? That work is distributed among the different systems, different terminals, different computers. See this? The distributed operating system is not installed on a single machine. In our example, 6 machines. Of course, the types of the machines are different, but in general terminologies, 6 machines are connected to a network. This is one network, and 6 machines are connected to the network. So the distributed operating system is not installed in a single machine. It is divided into parts. The operating system, the software, that is system software, is divided into some parts, and these parts are loaded on the different machine. Nothing but I have this operating system, distributed operating system, that is a software. And some part of that software is loaded here, and another part here, and another part like that. Different parts are stored in the different machines. A part of the distributed operating system is installed on each machine to make their communication possible. So with help of these different parts can make the communication. With help of this communication, the given work is distributed and executed by the different terminals or different parts or different machines. And finally, the partial results are taken back and create a final solution. So this is how distributed operating system works. Very simple. If anyone gives you any work, you are distributing your work, and assume that 6 people may doing their work part by part, and they are giving some result. You are creating the final result with help of the partial results given by the 6 people. Same approach implemented in the distributed operating system. Next. Next concept is functions of operating system. This is also very important topic. What type of the functions can be done with help of the operating system? First one is memory management. As we know already, memory in the sense primary memory. In this case, memory means primary memory. All the tasks, all the jobs, all the activities related to the primary memory will be maintained by the operating system. All the actions means what? Suppose if you want to execute any program, initially all the files are stored in the secondary memory. We know that we cover already. That has to be transferred to the secondary storage to primary memory, that is main memory for the execution purpose. So in the main memory, the CPU has to allot, the operating system has to allot some memory for that your program. Then only the program will be loaded into the main memory. If the program is loaded into the main memory, then only CPU can execute that. So allocating the memory for the programs is the responsibility of the operating system. That is a part of memory management. Or let me give one example. Already you executed one program. The execution is completed, but the operating system allots some memory to your program. After executing that, that program and program relevant data has to be removed from the primary memory. So deallocating the memory for the executed programs. This is also responsibility of the operating system as part of the memory management. So like that, in summary, create the memory for the programs or processes and deallocate the memory. So this is the response. These are responsibilities of the operating systems. And next important point is, as I covered, allocated and deallocating the memory. And the next one is, it keeps record of the which part of the primary memory is used by whom and how much. This is also responsibility as part of the memory management only, because five programs are five programs loaded in the main memory. Assume that six program is trying to store in the primary memory. The sixth program is sending the request to load into the primary memory. So the operating system has to keep record how many programs are available in the memory and which memory is used by which program and how much a program is still available in the memory, which program will be deleted after how many times, how many seconds of the time, how many programs will be deallocated, when the memory will be freed. Like this, complete information must be tracked by the operating system to continue the execution of the remaining programs. And distributes the memory while multiprocessing. As I covered, what is the meaning of multiprocessing? Multiple programs can be loaded into the memory. For that also, the memory has to be distributed. So all these are memory management relevant tasks. All these memory management tasks will be done by the operating system. This is one of the functions only. Like this, operating system has to do so many functions, so many actions. Second function is processor management, or you can say processor scheduling or CPU scheduling. All are valid terms. Every software that runs on a computer, whether in the background or in the front end, that is called a process. Or more simple terms, a process is nothing but a program in execution. Okay, a program in execution. Or more simply, right now, a program is being executed. That particular program at that particular moment is called process. Okay, complete complete program won't be loaded and won't be executed at a time. So part by part, the program will be loaded. So that part is called process. Okay. So the processor scheduling means depending on the processor schedulings only, CPU schedulings only, which process will be executed first, which process will be executed next, and what is the sequential order of the execution of the processes. All these will be decided based on the CPU scheduling algorithms only. And this is also work of the operating system. Operating system will take care about this. Third functioning is device management. As we know, so many devices we have in our laptop or PCs, personal computers. For all those devices, the operating system maintains the connections, and it has to maintain the drivers. Drivers is nothing but a particular type of the softwares. Those must be used if you want to work with a particular device. For example, I have a camera, let us say. If I connect that camera with help of the USB cable directly to the PC, that might not work, because the camera relevant drivers must be available in the computer. Then only the computer can identify that. Or more simple terms, printer. If you have the printer, you may have this experience. Directly, you may not work with the printer, because the printer's drivers must be installed in your system. This is a part of device management, how the operating system maintain the devices. Allocates and deallocates devices to the different processes, and keep records of the devices. How many devices are connected already, and what is the functioning way of the devices? Is the device active state or inactive state? Like this, it has to, the operating system keep getting the information of the all the devices, and decides which process can use which device and for how much time. This is also device management. Okay. We have several devices, several processes. Which process can use which device and for how much time? That will also will be decided and maintained by the operating system. Next function is file management. The operating system manages resource allocation and deallocation. Nothing but depending on your work, some resources must be allocated. It specifies which process receives the file and for how long. Okay. Suppose I am working with uh, one MP3 player, let us say, audio playing software that has to take one MP3 file. So how much time you want to listen that music, and which software may use which type of the files, and how long a different type of the softwares using different type of the files. So this complete record will be maintained by the operating system. And it also keeps the tracks of the information like location of the files, uses, status, and so on. Uses means some files may be in the write mode, some files may be only in the read mode. So that is different types of the using. Suppose I want to use one file for the reading purpose only, that is reading mode. I don't want to enter the data. Otherwise, some people may want to enter the data into the existing file. That using is different. The way of using is different. These grouping of the resources are referred as a file system, and the files on the system are stored in a different directories. Obviously, we know that the simple terms is we have the different type of the files in our computer. We are using folders to organize the data, right? And that is nothing but technically that is a directory, and simple terms folder. So for the file management also, internally the operating system maintains different directories. Storage management as functions of the operating systems. Already we covered one function, that is memory management, right? So memory management means that is about primary memory, main memory, that is RAM. The storage management means when we use the word storage, the meaning is that is secondary storage device, permanent memory. Okay. Now, we know that already the main intention of the secondary storage device is to store the data permanently. That is the main concept. Storage management is a procedure that allows the user to maximize the utilization of storage devices. The operating system is in charge of sorting and accessing the files. We know that already all the files are stored in the secondary storage devices. How to sort, how to store all the files. And suppose if you want to access a particular file, that should be opened by taking minimal time. For that also the operating system has to sort all the files. They used to maintain some mechanism, indexing mechanism to retrieve the data fastly. This is also a storage management technique. Storing, writing the data as well as retrieving the data or copying the files from one location to another location. All these will be maintained by the operating system. So that is storage management system because we are working with a secondary storage. The operating system uses storage management for improve the performance of the data storage resources and it optimizes the use of various storage devices. So with help of this storage management, we have different type of the storage devices now, like suppose pen drive, external hard disk, internal hard disk. Like that, we may use different type of the storage devices. All those storage devices will be maintained by the OS. Now, that is about the functions of the operating system. So if you get that question in the examination, you must write all those in brief because so many functions are there. At least you need to write few points about the one of the function, that is enough. Memory management, secondary storage management, files management, like this you need to write the functioning name as a subheading and write the points, few points about each and every functionality. It is better if you draw any meaningful image relevant to that functioning. Okay. Next one is kernel. This is very, very important concept. Kernel is a central component of a computer operating system. Kernel is, in simple terms, kernel is a part of operating system. Okay. If you want to know in simple, kernel is a part of operating system. Observe here, this is operating system box. Okay. This is operating system and this is outer part. Operating system is a system software, na? That is a software collection of the programs. So outer part is called shell and inner part of the operating system or inner layer of the operating system is called kernel. Next, the only job performed by the kernel is to manage the communication between the software and the hardware. Okay. Suppose I have one software, I am working with one software. That software wants to use some file, but we know that the file is stored in the hardware, secondary storage device, that is in hardware. Then how the communication is established between our software to that hardware component? This is the point. So this is the place where the kernel has to do some work. Kernel is the responsible to make the communication between your software to that hardware component. That is the important work of the kernel. As I said already, kernel is the innermost part of the operating system and shell is the outermost part of the operating system. See, this software, you are working with one software and that software is going to be connected with kernel. Kernel is the responsible to communicate with the hardware components. Suppose if you want to read some file data, that file is available in the hard disk. So your software is going to communicate with the kernel. Kernel is communicating with the hard disk and the hard from the hard disk that will get the data and kernel will submit that data to your software. Then you can open that file in your software. So these are the steps has to be done internally. So for that, the kernel is the main important here. Kernel plays the very important role here. Observe here, user. User has to connect with the terminal. Terminal means with which you are working. Okay. And the terminal is connecting to the operating system. And in the operating system, in internal part is kernel. Kernel is connecting to the hardware. And this kernel will get the information from the hardware. And again, after that, the kernel will give the information to the terminal. Terminal means with which you are working as a user. And with help of this terminal, you can do your work. So this is the sequence of these steps, and where the kernel is and what is the responsibility of the kernel is. Next important term is system calls. Generally, in the university exams, you may get this question, what is system call? And explain different types of the system calls. Very simple topic if you focus. Dual mode operation provides a layer of the protection between user programs and the operating system program. In simple terms, in the operating system also, we have two modes, two parts. One is user mode, second one is kernel mode. User mode means the execution is done on behalf of the user. All the user relative activities will be done in the user mode. And the operating system also has to do some work. Already, just now we covered, na, operating system has to do so many works, functions of the operating system. Memory management, storage management, file management, processor management. So in the kernel mode, the execution is done on behalf of the operating system. Operating system related relevant tasks will be done in the kernel mode. User mode and kernel mode. These are the two important modes you need to understand first if you want to understand the system calls concept. Then what is system call? System calls are the interface between a user program and the operating system. Though system calls are allowing the user program to request services from the operating system. They provide a way for the user level processes to communicate with the kernel. Let me summarize these points. I have one software and I want to use some data from the computer system. So this system call works as an interface between user program, that particular software or application software, and the operating system. Application software and system software, there is a difference we covered in the last session. Operating system is a type of the system software. Whatever the different softwares we are use, just like MS Office, PDF reader, browsers, all those are called application softwares. So whenever you are working with any application software, if that application software wants to get some information from your system, first that application software has to connect with the operating system. Then how this connection is established? This is the point where the system calls are used. System call works as an interface between your program or your application software and to the system software. The application software and system software, in between there is a system call. With help of the system call, we can get our required information. Suppose your software wants to use some memory. Then your software send the request to the operating system. But before that, the operating system uses system call. With help of the system calls, the particular memory will be allocated to you. We have the different type of the system calls. Now let me show you how does the system call works. Suppose your app, any app you are using that request system calls. And software interrupt system switches context to the kernel mode. As I said already, the operating system uses two spaces, user space and kernel space. And the operating system switch to the kernel space and with help of the system calls. Suppose that kernel is received one system call related to the allocation of the memory. So the kernel space receive that system call, identified and process that system call, and that memory will be allocated. The result will be sent to the your app. So this is how the system call works. Okay. Program makes a system call request. Operating system sees that system call. Operating system performs that operation, and operating system give control back to the program. So this is how system call works. Yeah, any doubts as of now?
No, sir.
Okay, in the next session, we'll cover types of the system calls. And after that, we will cover very important concept, what is process and life cycle of the process, difference between program and process. If time permits, this is very important and frequently asked question in the examinations, life cycle of the process. Okay, what is start, ready, running, terminated, wait, we'll cover in the next session. If time permits, in the next session, I will start CPU scheduling algorithms. That is very, very important concept. Probably 90% you will get the question from that area. Okay, right. So that's it for today's session. Still anyone has any doubts, you can ask.
Nothing, sir. Hello, sir.
Yeah. Okay, right. Thank you.
Thank you very much. హలో
ఏ
ప్రియా
ఏంటి నాకు
మా
అర్థం
సార్
సార్
నాడు
వెళ్ళిపోయారు ఏంది అడుగుతున్నా అక్కడ వాయిస్ వినిపించట్లేదు.
మన ఇద్దరే ఉన్నాం చేద్దాం రూమ్ మీటింగ్ లా
నేను ఇక క్లాస్ చెప్తా.
చెప్పు క్లాస్ చెప్పు
స్టార్ట్ చేయి.
హే యూనివర్సిటీ వాళ్ళు కూడా ఉన్నారు దాంట్లో జాగ్రత్త
వాము కట్ చేసేయి.
ఓకే బాయ్